Before we left for our break, we had an opportunity to talk about equivalent fractions and learn how to find equivalent fractions. Because fractions and decimals are different representations of parts of wholes, we can use that understanding of equivalent fractions to help us find equivalent decimals. So the first thing that we want to do is represent these decimals as fractions. So if I'm asking you to show me the fraction 8/10, I'm going to have a numerator of 8 and a denominator of 10. If I want to find an equivalent fraction for 8/10 that has a denominator of 100, there are two ways for me to determine that equivalent. One way is just to compare my denominators. I know that to get from 10 to 100, I'm going to need to multiply by 10. And when I'm finding equivalent fractions, whatever I do to the bottom, to the denominator, I have to do to the numerator, so I'm going to multiply that by 10 as well. 8 times 10 is going to give me 80, so I know that 80 hundredths is going to be an equivalent fraction for 8/10. The other way that I can do that and solve is by using cross multiplication. Remember, we always call it cross multiplication. It's not the butterfly method. The butterfly method is not a mathematical term. We want to use correct mathematical terminology. So I can't do 10 times this blank. This is what I'm trying to figure out. But I can do 100 times 8, and I know that 100 times 8 is 800. And since I'm looking for an equivalent fraction, I know that the product of this denominator and this numerator is going to have to be 800 as well. So I ask myself, what can I multiply by 10 in order to get 800? Well, if I multiply 10 by 80, I will get 800. So there's another way of finding that equivalent fraction. Now, when I'm taking fractions and turning them into decimals, and I've already represented these decimals up here, I'm going to take my fraction, 8/10, that's what I'll start with, and because I have a denominator of 10, it's already built in and ready to go into the 10th spot, right? Because my denominator of 10 is representing tenths. I have 8/10, so I'm simply going to move my numerator into the 10th spot, and I know that the 10th spot is directly behind the decimal. So I've taken my fraction 8/10 and represented it as a decimal. I can do the same thing for 80 hundredths. I have my fraction 80 over 100, 80 hundredths, and all I have to do is take my numerator and put it into the hundredth spot. So my hundredth spot is 2 spots behind the decimal. So I have 2 spots behind the decimal, 80. That 0 lands in the hundredths spot, so this is 80 hundredths. Now, I've already determined that these fractions are equivalent, so I know the same thing is true for my decimals. If 8/10 is equivalent to 80 hundredths, then 8/10 is also equivalent to 80 hundredths. One way to keep this super simple when you're going from tenths to hundredths and then hundredths to thousandths is just to add a 0 behind it. Right? If I have, for example, the decimal 4/10, and I'm looking to put that instead of the 10th spot into the hundredths, I simply am going to add a 0 behind. Now I have 40 hundredths, and that is the exact same value as 4/10. This is going to be really helpful when we go to compare numbers, compare decimals rather, and to order decimals. We are going to need to know that we just have that simple fix of adding that 0 behind. The same is going to be true for something like 6/10. If I wanted to find an equivalent that's in the hundredths, I simply add a 0 behind it. 6/10 has the same value as 60 hundredths.